Welcome to the second installment of Derby Test Track. Lubes Comparison. There are many good Pinewood Derby lubricant options, but we wanted to know if any were significantly better than the others. What's faster, dry or wet lubes? Watch and see what we learned. In this video we test 24 lubricants, both wet and dry. Some commonly used and some not so commonly used. This wasn't a spin the wheel with your finger and see how long it spins evaluation. We tested all 24 lubes with a specially prepared car, using new and identically prepared axles and wheels for each lubricant tested, and let the timer on our 42-foot aluminum track be the judge. Disclaimer: the content of this video is for informational and entertainment purposes only. Derby Test Track was not sponsored by or affiliated with the manufacturers or retailers of any of the products tested in this video, or the Boy Scouts of America, at the time of testing or production of this video. All lubes tested, as well as the axles and wheels, were purchased by Derby Test Track. Derby Test Track has made its best commercial effort to conduct all tests fairly and impartially, and to minimize non-lubricant variables which could impact test results. Your results could be different. The information provided in this video is believed to be accurate. However, Derby Test Track and the creator assume no responsibility for the accuracy of the information contained in this video, or injuries or damages resulting from the information provided or use of the products tested. Design of the experiment: we like videos that are concise and get straight to the point, and we're sure you do too. But when viewing comparative tests such as these, we also like to know how the experiment was conducted so that we can gauge the validity of the test results for ourselves. Since you are watching this video, you are probably like us. Our experiment was designed to minimize external variables as much as practicable, including the potential for lubricant cross-contamination, while providing information that is representative of actual race results. The objective of this experiment was to evaluate lubricant performance, not wheels, axles, or alignment methods. Those will be the subjects of future videos. You may wonder why we did not bend axles or make the car a rail rider. The answer is that the slightest difference in our positioning of the axles, or amount of rail riding from one test to the next, would introduce an unintended variable. We are making comparisons in the thousandths of a second. As best we were able, we wanted the lubricant to be the only variable from one test to the next. Therefore, the times in this experiment will not be directly comparable to those of a perfectly tuned, bent axle, rail rider with official BSA wheels and axles, using the same lubricant. Experiment parameters: 1. A new set of 4, unpolished, maximum velocity nickel speed axles were used for each lube tested. We initially wanted to conduct these tests with BSA axles, and got halfway through our testing using commercially available polished axles, until it became painfully clear that the dimensional inconsistency in those axles was skewing our test results. So, we started over again with new wheels and maximum velocity nickel axles, every one of which had a diameter of 86 thousandths of an inch. However, the day using the BSA polished axles wasn't completely wasted. Those 150+ runs helped break in the lane on our still green track. 2. A new set of unpolished maximum velocity precision wheels were used for each lube tested. Wheels were cleaned with 91% alcohol prior to lube application to remove any mold release. These wheels were selected for their similarity to official BSA wheels and excellent uniformity and quality. 3. The same long wheelbase car body was used for all tests. 4. Test car weight was 5 ounces, with center of gravity 1 inch ahead of the rear axles. 5. Great care was exercised in the construction of the test car body to ensure that the internal axle holder and locking assemblies were accurately positioned, to provide zero camber and zero toe, helping ensure that the axles used on each test run would be held in the same position as the axles in other test runs. A 60 thousandths lift of the left front axle was built in. While this may not have been the fastest configuration, it provided the greatest alignment consistency from one test run to the next and minimal guide rail contact. 6. Where each wheel contacted the car body, a fresh piece of matte finish Scotch tape was applied for each lube tested. 7. A starting position alignment jig was used to help ensure that the car had the same starting alignment from one run to the next, and that the wheels had the same wheel-to-body spacing at the start of each test run. 8. The center lane of our 42-foot best track, with leveling kit and champ timer, was used for all test runs. Test runs were conducted indoors at 74 degrees Fahrenheit. 9. Unless otherwise stated, the default liquid lube application procedure was as recommended by Derby Works and Pinewood Derby for their Krytox lubes: 2 drops on the axle, spread with fingers, insert axle in wheel and spin wheel, remove axle and wipe off any excess lube. 10. Unless otherwise stated, the default dry lube application procedure consisted of impregnating the bore of the wheel hub by applying the lube to a short length of pipe cleaner, inserting the pipe cleaner into the wheel hub, and spinning the pipe cleaner at low speed with a drill. Similarly, the axles were mounted in the chuck of a drill and the lube was worked into the axle with a piece of paper towel. A small amount of the dry lube was then applied to the wheel hubs, and the wheel spun by hand prior to the test run. Pledge wax was not used as pre-treatment for dry lubes, as we wanted to determine the performance of the dry lube, not the wax. Lube was applied to the inside edge of all wheels, where the wheel may come in contact with the guide strip. A note here. In other tests, where we ran the same silicone lube application over 60 times, we observed that loss of lube on the inside edge of the wheel, due to guide strip contact, was the primary cause of increasing ETs. ETs could be restored by relubing the inside edge of the wheel without relubing the hub and axle. 11. 7 runs were made with each lube to determine the durability of the lube application. Lastly, a note about measurement uncertainty and random error. There are many factors that impact a car's elapsed time, and lubrication is just one of them. While comparing the test run results of each lube, as well as individual test runs of the same lube, bear in mind that there is always some level of inherent variability, or random error, despite our best efforts to control and eliminate variables. Track joints are never perfectly smooth and guide strip contact varies from run to run. On with the test results. Shown here in no particular order, are the 24 lubes we tested by type. We tested 6 dry graphites and graphite molybdenum blends, 8 liquid silicones and perfluoropolyether oils, 4 dry non-graphites, and 6 liquid non-silicone lubes. We ran each lube 7 times. We determined the best single run time for each lube, the worst single run time, the range of best to worst time, the average elapsed time for each lube, the standard deviation of ETs for each lube. Standard deviation is a measure of consistency. A quick way to see if the test runs for that lube were all over the place, without graphing the results. Low SD values mean the 7 run times for that lube were more consistent. A low standard deviation is not a measure of speed, only of consistency of ETs. Even a slow lube can have consistent, closely grouped, elapsed times. And the median elapsed time for each lube. In the final analysis, we have ranked the lubes by the median elapsed time of the 7 test runs for each lube. Using the median, as opposed to using the average time, is preferred because unlike the average, the median does not consider best or worst data outliers. The median is literally the time in the middle. Asleep yet? Hang in there. The statistics lesson is over. We're getting to the individual results. A note: if we observed the ETs for a lube trending faster as we approached the 7th run, we would continue to make runs to see if the ETs continued to trend downward. While the ETs for one lube held steady past 60 runs, we did not observe the ETs of any lube steadily improve past 7 runs. There are many very good lubricants here, with less than 80 thousandths of a second between the top-ranked lube and the 19th ranked lube. And less than 50 thousandths of a second between number 1 and number 16. There are a few lubes here that work well in motorsports, shooting sports, and industrial applications, but based on our tests, are not good choices for the light-duty, low-temperature demands of Pinewood Derby. To help put into perspective the difference in lube times from one lube to another, let's consider the spread between winning and losing, from a sampling of the more competitive, closer, heats in an April 2024 council race. Again, we want to stress that these were the closer races, not all races. Even at the council level, races were still being won or lost by 1, 2, even 3/10 of a second. In close races, the average win or lose time difference between any two cars was 44.8 thousandths of a second. Using our median lube test times, that is the difference between the top-ranked lube and the 14th ranked lube. The closest time between any two cars was 7.5 thousandths of a second. Graphites and graphite molybdenum blends were 4 of the top 5 performers whether looking at the median or the average elapsed times. Of all the runs, graphite and graphite molybdenum lubes clocked the 3 fastest ETs. Graphite has been a staple of Pinewood Derby racing for decades given its low cost, compatibility with plastic, low friction coefficient and lubricity, and layered structure that allows easy shearing between layers. It also adheres well to metal surfaces, like our axles. The downside of graphite is that it eventually gets compacted, reducing lubricity as the particles become clumped together and lose their dispersion, causing times to decay with enough runs. And, as you can see from our test car, it is messy. That said, we did not observe any significant decay in ETs of the graphite lubes over the course of the 7 test runs. How many times your car will be run on race day depends upon the number of scouts, number of track lanes, how the race is conducted, and how quickly your car is eliminated. If your car performs well, you may want to plan on it being run 8 times on race day. As you view the following slides of individual results, next to the table of times for each lube, is a photo of the timer reading for the best ET for that lube. The number in the blue circle on the tag indicates on which of the 7 test runs the fastest ET was recorded. Based on median ET, the number 1 and number 2 performers, Pinecar XLR8 Ultra Graphite, and Pinewood Pro Graphite, were extremely close, virtually identical. XLR8 had a slightly faster median ET. Pro Graphite had a slightly faster average ET. Hodges Hobby House GM Lube, Maximum Velocity Max V Lube, and Pinewood Derby Turbo Lube, were a close 3rd, 5th, and 6th. We have some history with Hodge's GM Lube. We won all our council races, taking both first and second places, from 1987 to 1991, with Hugh Hodge's graphite molybdenum blend. We were interested to see if this lube, now marketed by winderby.com, was still competitive. Only David's Warp 9, the identity of which will be revealed later in this video, was able to break into the top 5 with the graphites. We will tell you exactly what David's Warp 9 is, where you can get it, and how to apply it. You may already have it in your home. In 7th place, Derby Dust Prol Silicone Oil was the top performing liquid lube. Derby Dust indicates a prol viscosity of 5 centistokes, and the oil flowed like water. Water is 1 centistoke. At 5 centistoke viscosity, Derby Dust's prol is the lowest viscosity lube we tested, matched only by Clearco's PSF 5 CST silicone. The exact formulation used by Derby Dust was unknown at the time of testing. In 8th place was Turtle Wax, Flex Wax, Liquid Polymer Graphene Blend. This was one of our "why not? Let's try it" choices. Like some of the other less common lubes tested, Flex Wax can be sourced from a variety of stores, and is not prohibitively expensive. Unlike all but one other liquid lube we tested, Flex was applied to both wheels and axles and allowed to dry overnight before testing. In 9th place, Super Lubes Silicone Oil 100 CST, a low viscosity, 100 centistoke, silicone oil. At $15 for 4 ounces on Amazon, you could lubricate your entire pack. We used this lube for our weight and center of gravity tests, as it provided consistent elapsed times for over 60 runs. It wasn't until near run 70 that we saw a decline in ETs. Pinewood Pros Nye Oil 2 ranked 10th. This is a low viscosity, 105 centistoke, highly refined petroleum oil, aka mineral oil. At the time of testing, the exact formulation and viscosity of Pinewood Pros Nye Oil 2 was unknown. We suspected that this might be identical to Nye Lubricants Nye Oil, and maybe it is, but Nye Oil 2 outperformed Nye Lubricants Nye Oil on both maximum velocity speed axles and polished BSA axles. 11th was Lemon Pledge. We first heard of the use of Pledge as a Pinewood Derby lubricant back in the 80s. When sprayed into a cup, the Pledge foam settles down into a white viscous, semi-liquid wax. The wax was applied to the wheels by dipping a short piece of pipe cleaner into the wax, chucking it into a hand drill and working the wax into the wheel bore. A clean 12-inch pipe cleaner was then drawn through the bore to remove excess wax. The wax was also rubbed onto the axles and then wiped off. 12th, Derby Dust, another graphite lube. There was less than 37 thousandths of a second between the median ET for Derby Dust and the top-ranked lube. In 13th, and with a median ET of less than 40 thousandths of a second behind the top-ranked lube, was Clearco's PSF 5 CST Pure Silicone Oil. Its 5 centistoke viscosity is the lowest viscosity silicone product offered by Clearco that will not evaporate. Its viscosity is even lower than Krytox GPL 100's 12.4 centistoke viscosity. Less than $100 can get you a full quart of this lube. 14th ranked was Nye Lubricants Nye Oil, Liquid Mineral Oil. Nye Oil is a low viscosity, 105 centistoke, highly refined petroleum oil lubricant, aka mineral oil. This lube has been around since silent movies. In the 15th slot was Super Lube O-Ring, Liquid Silicone Oil. A low-cost, extremely viscous, 5,000 centistoke viscosity, silicone fluid. As with other wet and viscous lubes, it is important not to over-lubricate. This lube had good consistency from one run to the next. In the 16th, 17th and 19th positions were Maximum Velocity Pro Extreme Krytox Oil, Pinewood Derby Krytox GPL 100, and Derby Works Krytox GPL 100. All three were within 30 thousandths of a second of each other. There are 4 Chemours Krytox oils with viscosities below 100 centistoke. Krytox GPL 100 being the lowest viscosity in the Krytox series, at 12.4 centistoke at 20 degrees Celsius. The exact formulation and viscosity of the Krytox product used by Maximum Velocity was unknown at the time of our testing. Maximum Velocity states that Pro Extreme Krytox is a blend of low viscosity base oil and friction modifiers. We viewed the close placement of the 3 Krytox lubes as a validation of the experiment's sensitivity. In 18th position was White Lightning Epic Ride, Bicycle Chain Lube, that is composed of silicone in a heptane, light distillate carrier. The product dries to leave a silicone film. The caution with this product is the heptane. Heptane is a solvent and will soften and swell many plastics over time. We applied this to the wheel bore and axle and allowed it to dry overnight. Number 20 was Bullet Coatings Half Micron Boron, Dry Hexagonal Boron Nitride. An extremely fine, white powder, with a structure and lubricating properties similar to graphite. One thing to like about this is that it doesn't make the mess that graphite, molybdenum and tungsten disulfide make. At 21 was pure castor oil. We're always looking for a lube that is both good and cheap. Castor oil is a relatively viscous, 650 centistoke, castor seed oil. Castor oil was the go-to lubricant for racing two-cycle motors for decades. It is just not a good fit for Pinewood Derby. At 22nd and 25th place, considering no lube as the 24th finisher, are Lyman Super Moly, molybdenum disulfide, and MK, WS2-06 tungsten disulfide. Molybdenum disulfide is a low-friction solid lubricant, composed of layers held together by weak forces, thus allowing sliding of its layers. Like graphite and tungsten disulfide, molybdenum disulfide is difficult to handle without making a mess. We have used both molybdenum and tungsten disulfide to great success in shooting and motor sports. However, in the case of tungsten disulfide, it performed worse than no lube at all. In 23rd place was micronized Teflon. Given the large minimum purchase quantity, this was an expensive buy for this test. With the waxy feel of this extremely fine powder, we thought it would have performed better. Like graphene, it was near impossible to get this powder to stick to the axles or stay in the bore. We promise to reveal what David's Warp 9 is. But before we do, we'd appreciate a like and your subscribing to our channel for more content like this. Thank you. We will now reveal the identity of the third overall ranked lubricant, and top ranked non-dry lubricant, we called David's Warp 9. Allow us to introduce you to David, Derby Test Track's YouTuber, David's Warp 9 namesake, Derby Test Track's Cub Scout and 8-year-old Taekwondo black belt. It's the night before the pack race. As usual, Dad procrastinated and didn't help you build your car until this afternoon. You even had to leave the spots where the wheel hubs contact the car body unpainted, because the paint would not have time to fully cure. No time to order a specialty lube. No time to go to the hardware store for a tube of graphite. Can't use petroleum oils because they are too viscous and the risk of softening the plastic wheels. Is there anything around the house or available at the late-night grocery store that could be a competitive lube? Yes, there is. And you may already have it in the pantry. Crisco vegetable shortening. Since Crisco vegetable shortening is a semi-solid grease, we used the same wheel and axle lubrication method as we used for Lemon Pledge. We were dumbfounded with the ET of the first run and expected it to be a fluke, but it continued to get low ETs. Still thinking that the results were a fluke, we tried it again with different wheels and got nearly identical times. ETs did begin to degrade as we pushed the Crisco past 8 runs, so it does not have the insane long durability of some liquid silicone lubes. In addition to the benefit of being low cost, readily available, plastic compatible, no dust inhalation risk, and being safe to consume, Crisco doesn't make the mess that graphites do. If you are using an already opened can of Crisco, be sure it was not contaminated by sugar, flour, etc. from previous uses for baking or cooking. Scrape off and discard the top layer of Crisco if you suspect it may be contaminated. This was our first exposure to Crisco as a Pinewood Derby lube. We suggest caution if selecting this for use in the dead of winter if the car gets cold and it is going to be cold in the race hall. We will definitely give Crisco a try. It is a highly competitive lube choice. One last observation we'd like to share. While the ability of a wheel to spin for 20+ seconds with no load on it is a favorable indicator of on-track performance, it is not a reliable indicator of how a lube will perform under load on the track, particularly with liquid lubes, waxes and our new friend, Crisco. Thank you for watching. We gave our track the cleanest and most consistent test inputs we could, and let the timer tell us what it saw. We have been transparent with our viewers regarding our test procedures, and have not waited, cherry-picked, or adjusted the data in any way. Like you, we are racers, and want to know what works best. We are not afraid to share our knowledge with others, as good competition drives innovation and makes the competition more exciting. We hope you will share this video with others. Whether you learned something new along with us, or this experiment confirmed what you already knew, we hope you found this installment of Derby Test Track useful, informative and educational, and that this information helps make your next Derby a more rewarding and enjoyable one. If this information was useful, subscribe to our channel. We have other Pinewood Derby videos in production. If you are truly appreciative of our work product, you can support us through our Patreon account.